Hello, my name is Konstantinos Gabriel. I'm a physicist, and together we are going to draw this circuit, this parallel connection circuit of resistors in the circuit simulator of the Falstad applet. Okay, now let's get started. We are going to see also the contents and what do they ask. They ask from us to, after we draw the circuit, to use the ammeter and the voltmeter in order to fill this uh, table. Okay, let's get started. First of all, we go to the draw option here on the toolbar. Let me use my annotate here. Okay, to the toolbar, we are going to go to the input and sources because we want a voltage source. Afterwards, in order to insert to the circuit an ammeter and a voltmeter, we are going to use the outputs and labels. Okay, now we are going to use the inputs and sources in order to insert. Okay, our voltage source with the two terminals is this. Afterwards, I'm going to add a wire. Be careful to the connection to be in every part of the circuit that I insert to it. Okay, I need to insert it in a proper way to the connection points that you see. I connect the one part with the connection point of the other part. Okay, now let's draw again our resistors in a parallel way connected. One resistor here, one other resistor here. Again, let's make it something like that. We are going to draw the wires. Add a wire here, here, from here to here, from here to here also. We need one more. Draw, add a wire. Let's make it in a longer distance in order to have space after to put the voltmeter that I will use. Okay, draw here. I'm going to put my new resistor over here. Okay, here we are. Okay, now let's move a little bit. In order to move a part of the circuit, I need to choose the draw option from the toolbar and go last line down, select and drag. Now I'm going to drag this resistor over here. As you can see now, we have red points, you see, because we do not have the correct, the proper here connection points. As you can see, the wire here, the wire's connection point is over here. So I will move the connection point here. Okay, now it is okay, and I will make it larger here. You see here on the top, in this area, we have a good connection. On the other side, we have a bad connection, so we are going to fix it too. From here, I'm going to drag, and from here also, in order now, okay, we have our circuit working, operating. Now, let's see the values of the voltage source and of all the resistors. We have a 4.5, a 270 ohms, be careful, ohms, not kilo ohms. After we have 1 kilo ohm and 2.2 kilo ohms. Now, double click on the source. Okay, I double click on the source and I change the value of voltage to 4.5 volts. Okay, now I double click on the resistor and I will change the value to 270. Only 270. I will not put kilo because the kilo option gives me the meaning that I have kilo ohms. 270. Here is in the middle the resistor is okay, and now I'm going to the third one to put to 2.2 kilo ohms. Apply and okay. So you can see that the current is flowing faster on the first left loop. Okay. After we have a slow end from the branch here that it is 1 kilo ohm. If you compare the branch of the 270 ohms with the branch of the circuit, the branch of the circuit of 1 kilo ohm, you see that we have a faster flow from this part. We have higher current passing through it and lower current passing through the 1 kilo ohms resistor and a lower in 2.2 kilos. So let's continue. What does our exercise say? We have put 4.5 to the output. Now we are going to use an ammeter. Here it says use an ammeter and measure the current at A, B, C, D, and E. Where are these points? Let's see. The A is here. The B is here. C, D, and E. You see. Now in these places, in these points, we are going to connect the ammeters. So let's put the ammeter. What am I going to do? I will choose I have the select tool, okay. I will choose here the resistor. I will make it a little bit smaller, okay, in order to insert my ammeter. And how do I insert my ammeter? Now I go to the outputs and labels. You see, before, in order to add the source, okay, I have chosen the inputs and sources. Now I choose the outputs and labels for the ammeter and voltmeter, and I go down here to the ammeter. I am careful to go to the right connection points, and here it is now. The same way, by the same way, I'm going to select the select tool, okay. I'm going to choose my resistor. I will make it a little bit smaller in order to join here the ammeter from the draw toolbar, outputs and labels, ammeter, and let's start. Where are we going to connect it? Here, where, as you can see, we have the right connection points right here, from here to here. If I make an experiment, let's say, and I want to connect it somewhere else, see what happens. I'm going to do it in a wrong way now in the third one to show you that now outputs here again, ammeter here, select and drag tool in order to make smaller, okay, my resistor. I will drag it, okay, and now I'm going to insert here inputs and sources, outputs and labels, the ammeter. Now I'm going to connect it in a wrong way, okay. I will make here the connection. As you can see now, I have a red point here because it is the wrong place, the wrong point that I have connected the wire with the ammeter. Now I'm going to drag my ammeter's connection, select tool, select my ammeter. I will go to the connection point and I will move it here. Now it is okay. Okay, as you can realize, we need to connect to the specific places our parts. The parts of a circuit are called components. So when you see an expression or a word the word component in a circuit, that they tell you components. Components means parts of the circuit. The resistors are components, parts. The voltmeters, the voltage source is a component. Okay. Now, I'm going to write the values of the ammeters. You see here, the first ammeter in the A, they told me to make another connection. Excuse me here. I'm going to connect on this side an ammeter here and an ammeter here. Okay, draw, because this is how they asked me from the sketch, from the, okay, inputs here, outputs ammeter, and I will bring my ammeter from here to here, and after I will put another ammeter from here to here. That's why I have removed the cables. Okay, so now as you can see, let's make some discussion here. We have the ammeter, we have the voltage source with the 4.5, and this causes a current flowing with 23.2, okay, milliamperes. So this current enters to the first branch, to the second branch, and to the third branch. First resistor, second resistor, and third resistor. As you can realize now, you see that according to the Ohm's, to the Kirchhoff's law, that the current that enters, okay, a node is equal to the algebraic sum of the currents that go out of the uh, of this node. And as you can see now, 16.6 plus 4.5 milliamperes plus 2.045 milliamperes give me 23.212 milliamperes. Okay, according to the, let me write this to you, write the law Kirchhoff. According to the Kirchhoff's law, we have that the, sorry, we have here that the I equals to the I1 plus I2 plus I3. You see, here is the I, here is the I1, here is the I2, okay, and here is the I3. So these three currents are equal, the sum of these three currents are equal to the I, to this one. Okay, now we are going to fill our tables. What do they ask from us? Okay, let me see. They ask from me to do what? To fill this table here. Go to the table. I have 4.5 volts. Here I have a current at the A, which is here. Okay, the current is here, the A point. So we are going to fill all the values. In the beginning, in A, we have 23.212. So 23.212 milliamperes. Okay. After we have 16.667. 16.667. Okay, these 4.5 milliamperes, we can round them. Okay, 4.5. Now we are going to write it as they are. 2.045 milliamperes. 2.045 milliamperes here. Okay, And here in the E is here. Okay, so you see that the current that it is coming back, again, it's 23.212 milliamperes. Now they ask from us to write the voltage drop across every resistor, R1, R2, and R3. That's why they ask from us to use a voltmeter to measure voltage across resistors. Okay, now I'm going to enter draw outputs the voltmeters. Okay, voltmeter. I am going to pick 3 voltmeters. Okay, 1 voltmeter here, 1 here, and 1, let's say, here. You see, I don't join them with the wire because it will be a wrong connection. I will choose my wires, draw here, add wire to the terminal, to the join connection in a proper way. Be careful to join in the proper way. Here the voltmeter with the the point connection. Okay, and here the voltmeter with the right connection. Here to the connection points. This is the concept, because otherwise we are going to have red points. So here now we are going to enter the value, and as you can see now, we have the same value for the voltage drops in every resistor. Why? Because they are in a parallel way connected. So 4.5 is the value that I am going to enter in every one of these cells. 4.5 and 4.5, which is equal to the value of, okay, of what? Of the voltage source. Okay, the voltage source in a parallel way connected with the resistors. That's why we have everywhere 4.5. Here it is the 4.5 for the milliamperes to make it a little bit nice. Okay, to make it nice here. Okay, and this is the table, the full table. After we are asked to change the value of the power supply. The power supply is the voltage source, and make it 9. Okay, we are not going to make all this again. We are just going to check and use the double click in order to change the value of the voltage source. Make it 9, apply, and okay. And as you can see here, we have 9 voltage everywhere with different currents according to the Kirchhoff's law. So we are going to continue with another interesting video after this one.